Hello friends, myself Professor Amit Sagar, and in this video we are going to learn practical on subject embedded and real-time operating system. Okay, so the practical which we are going to learn in this video tutorial is implementation of Semaphore for synchronization in the uCOS-II. Okay, so while learning this practical, first of all we are going to learn some theoretical concept related with the semaphore. Okay, so let us begin with our aim. What is the aim of this particular experiment? Okay, so aim of this particular experiment is implementation of semaphore for signaling and synchronization in the uCOS-II. Okay, so what is problem statement for this particular practical is we have to write a program for implementation of semaphore as synchronization device between two tasks. Okay, so what is a task 1? Task 1 will roll LED from left to right, and the second task is to roll the LED from right to left. Okay, so task 1 is having a different priority and task 2 is having different priority. So how these two tasks are going to be synchronized using the semaphore, that we are going to learn. So what is the learning objective of this particular practical is we can understand the configuration of semaphore in a different modes. Also we can find the solution to the shared data problem. Okay, so what equipments are required for performing this practical is we require the trainer kit of ARM7, that is nothing but the LPC 2148. Then we require serial cable, power supply, and we require the system with the Kill Microvision for software and Flash Magic. Okay, so this is what the requirement for performing the practical. Okay, so let us understand a few theory point regarding this particular. Now basically a semaphore is a mechanism and it was invented in the mid of 1960 by the Dijkstra. Okay, so and basically what is a semaphore? It is a protocol mechanism offered by a multitasking kernel. Okay, so why this mechanism is required? Okay, so this semaphore is used for control access to a shared resource. So that is the main reason this semaphore was invented. Okay, then next application of the semaphore is to signal the occurrence of event and to allow two tasks to synchronize their activity. Okay, so these are the three major reasons why the semaphore has become popular among this multitasking kernel. Okay, so generally we have observed that in many of the tasks, if same resource is used, in that case there can be chance of what we can say the resource can get a problem due to the multiple task access. If one resource is accessed by the multiple tasks, then we cannot get the expected outcome from the particular resource. Okay, for example, if we want to print two PDF files, and if you give the print command simultaneously for both the PDF file, so the printer has to differentiate the two files. Okay, so it means that the printer has to print the PDF1 and PDF2 separately. Okay, even though if they are giving the even their PDF files are accessing the printer at the same time, so the printer should provide the printer should be the mutual exclusion should be there. Okay, so the mutual exclusion is a very important whenever you are having a single resource and that single resource has been shared among the number of tasks. Okay, now how this problem is resolved by the semaphore, that we will understand. Okay, so what is semaphore? Semaphore is nothing but the key code it acquire in order to continue the execution. Okay, semaphore is nothing but the key and the code which acquires it can continue the execution. Okay, so if semaphore is already in the use, the requesting task will be suspended if the semaphore is released by its current owner. Okay, that means if one of the tasks is required semaphore and if another task is using the same it is having a key, then the requesting task will be suspended till the executing task does not release the key. So that is a simple meaning of this. It simply means that the task which is having a key, it will be having a access to the semaphore or it will be having a access to the particular resource. If the task does not have the key, it cannot access the particular resource. Okay, it will be suspended till it does not acquire the key. Okay, so that is a simple meaning of the semaphore. Now there are two types of semaphore. One is a binary semaphore and the second one is a counting semaphore. Okay, so binary semaphore can take only two values 0 and 1, whereas the counting semaphore can take value it can take the numeric value. Okay, now the value for the semaphore key, this range is totally dependent on whether the semaphore mechanism is implemented using 8-bit, 16-bit or 32-bit. According to that, the semaphore keys are assigned by the particular kernel. Okay, so the different operations are required for the semaphore mechanism. Okay, and we will understand one simple diagram how the semaphore can work. Okay, so let us understand in a simple way the semaphore mechanism, right? So right now the two tasks are there, task 1 then task 2. Okay, so if the task 1, now the semaphore is nothing but the we can say that it is a mechanism. Okay, the semaphore is nothing but the mechanism or it provides the key. Okay, if the task 1 is having a key, okay, now why this semaphore is required? The problem is that the printer is only one. This is nothing but the resource. Your printer is basically a resource. Now the same printer is required by task 1 and task 2. Now in such case, whenever there is a one single resource or limited resource, we have to provide access to the particular resource with the help of semaphore. Now the semaphore will decide who has to give access to the printer. If the task 1 acquire the semaphore, then the task 1 can be able to print. And if task 1 is executing, the task 2 will be suspended till the key is released by the task 1. Okay, so it is as simple as that. If the task 1 does not release the key, the task 2 will be suspended or it will go in the wait state. Okay, then if the task 1 releases the key, then task 2 can acquire the semaphore. Okay, so this is as simple as that. So Semaphore has resolved the problem of shared resource. Okay, so now with the help of practical, we will understand how the semaphore mechanism can work. Okay, so I will just close this PDF, and here in this particular I have opened the code for the uCOS-II semaphore code. Okay, now basically this coding for semaphore implementation has been done in the Keel Microvision 4 software. Okay, now how to create a project for uCOS-II, that for that purpose you can refer my prerequisite video. Okay, already I have created video on how to create a uCOS-II project in the Keel Microvision. Okay, so I am going to share the link regarding same, so you go through that, then only you will understand how I have created this whole file in the Microvision 4 software. Okay, so whenever we create any uCOS-II project, it will be consisting of 3 folders. First folder is app folder, second is a uCOS-II, that is a port files, and the third one is a port specific files or the hardware dependent. Okay, so here we are using the ARM7 controller, that is why we are having this ARM folder. Okay, so under every folder the different files are given. Okay, so under uCOS-II the different files are given: core, flag, mbox, memory, mutex, okay, queue, semaphore, task, time. Okay, so all these are the port file which is already provided by the it is already given downloaded from the uCOS-II website. Okay, then this file ARM, now this is actually the microcontroller specific files. Okay, and then in application we have different files. Okay, so serial.c, main.c and target.c. so these 3 files we have to program. So particularly our focus is on main.c. Okay, so here on in main.c we have to write the code for this particular semaphore. So let us begin with the understanding of the code. So first 2 line of code is showing the header file config.h and standard library.h. Then after that we have defined a constant with a 100 value, and so for serial communication we are using the function serial initialization function, and the serial initialization function is declared in another file and we are using here, that is why we are referring as a extern. Then after that we are creating 2 stack with the size of 100. Okay, so how stack is created? Using os_stk. so using this we have declared the stack for task 0, okay, and task 1. Okay, so here we are creating the two tasks, that's why two stacks are declared in this two lines. Then very important one, os underscore event print same. So here we have created a semaphore event, okay, semaphore event, and we have created a pointer variable print same, okay. Then we have declared the two tasks, that is task 0 and task 1, and under that we have given the parameter star p data, okay. And then comes your main function. In main function we are declaring the port 1 pin number 16, 17, 18, 19 as a output pin using the IODIR register, okay. So these 4 pins we are using, and to this 4 pin we are sharing among the two tasks, okay. So this is for declaring the port pin as a output, okay. So pin number 16, 17, 18, 19, we are connecting this to the LED, okay. So therefore we have to declare this as a output pin. Then we have initialize the serial communication. Then target board is initialized using this target initialization function. Now in order to use the uCOS-II function, we must have to give the command os init. If you don't give os init function, we cannot use any of uCOS-II commands. Then we have created a semaphore. Now to create the semaphore, the function is os semaphore create, okay. So we have created a single semaphore, okay. We have created only a single semaphore, okay, because we are having only one resource, that is nothing but the LEDs. Now two tasks we are here creating, okay. So the first task is task 0, okay, and its priority value is 2. Then second task we have created task 1, and its priority value is 3. That means the task 0 is having a high priority and task 1 is having a low priority. And then after creating a task, os start is given. Whenever we give the os start command, then only the execution is going to be started, and the uCOS-II starts the multitasking, and finally the return 0, okay. Now we'll focus on what is a task 0 and task 1, okay. So first of all, I explain the task 0. The same kind of code will be for task 1. So void task 0, then star p data, okay. So star p data is actually the parameter. Here one variable we have declared integer n. Now that we are using for left shifting or right shifting, okay. So therefore we are using this as a integer n. Then second variable unsigned integer 8 ERR, that is for storing the error code. In case if there is any error is occurred, then that will be stored in this particular variable. Then we have given the instruction p data equal to p data. Basically this is required to avoid the compiler warning, okay, because in the task, in declaring the task, we are assigning the parameter star p data, but actually this star p data, or we are not passing any parameter from this task 0 to any of the task, okay. So that is the reason, to avoid the compiler warning we have to give this command, we have to give this instruction. Okay, then after that, while one loop is there, that is nothing but the infinite loop. Okay, so what is first instruction? Task 0 is waiting, that we have printed. Then we have created a OS semaphore pending print same 0 error. Okay, so basically semaphore pending command is to acquire the semaphore. Okay, it is waiting for semaphore. Okay, in order to get the semaphore, we have to give this command. So until the semaphore is acquired, it will not execute the further instruction. Okay, so once the semaphore is acquired, then it will print acquire semaphore by task 0. Okay, now after this semaphore is acquired, then this particular code will be executed. So what is this particular code? That is, we are turning the LED on. Okay, we are turning the LED from left to right. Okay, we are turning the LED from left to right, like that. Okay, so this is the code, IO set, then IO clear. Okay, so using IO set and IO clear, we are blinking the LED from left to right. Okay, so this is how we are doing the task. Okay, when we acquire the semaphore. Okay, now once it is done, then semaphore will be released. To release the semaphore, OS semaphore post command will be given. Then it will print release semaphore by task 0. Then delay is also given of 20 milliseconds. Now the same kind of code is for task 1. Okay, in task 1 again, integer n is for counting the LED rotation. Then unsigned integer 8, again same for the error. Okay, so when this task, in this task 1, what is the first instruction? Task 1 waiting. Then it is also having a semaphore pen, OS semaphore pen command. Okay, so task 1 is also requesting the access of semaphore using this pending command. Okay, now it will wait till the semaphore is acquired. If semaphore is not acquired, it will go in the wait state, or it will be suspended. Until the semaphore is acquired, it will not go to the further instruction. Once the semaphore is acquired, it will print acquire semaphore by task 1. Okay, and then after that, once the semaphore is acquired, the LED control will be taken by this task 1. Okay, and then it will turn the LED from right to left. The LED will be turned from right to left, and for that purpose this for loop is given. Okay, so this for loop, it is for turning the LED from left to right. Okay, one by one LED will be turned from right to left, and once it is done, okay, so actually there are 4 LEDs, so 4 LED will be turned one by one from right to left. That task will be done. Okay, then once this is done, the semaphore will release. Semaphore will be released, and it will print release semaphore by task 1. So what is the main purpose of this particular is the task 0 and task 1 both are using the LEDs which are connected to the port pin number 16, 17, 89, 19 of your port 1. That means the LED is a single resource and the same resource has to be used by task 0 and task 1, but the only task will be the task which is having a semaphore can only able to blink the LED, or it can be able to modify the LED pattern. Okay, so this is very important thing. Now we will understand how we can do the execution. So for execution, here I am clicking on the build. Okay, so here you can see the 0 error and 0 warning. So let us debug the code. Okay, so it is showing evaluation mode running with the code size of 32K. So here I click on OK. Now we have to see the output on peripheral. Okay, so click on GPIO slow peripheral. Now port 1. Okay, so here our LEDs are connected to the pin number 16, 17, 18, 19. Okay, so these 4 pin we have to observe. And one more thing we have to observe is our serial UART window. Okay, so our serial window is available here. So I click on this particular UART 1. Okay, so let us magnify this particular window, and we will observe this bit number 16, 17, 18 and 19, and also we will observe the UART 1 window. Okay, so for output I have to click on this run button, and just for a moment I am clicking on the run button, and then I have to stop. Okay, because this is a continue execution, and we cannot be able to understand this. Okay, so here I click on run button. Now you can see bit number 16, 17, 18, 19. Okay, so this particular pin, yes, you can see here. Okay, so left to right and right to left. Okay, now in this UART window you can able to see. Okay, so task 1 waiting, release semaphore by task 0. Okay, I just stop here. Yeah, now you can see. So whenever acquire semaphore by task 0. Okay, so whenever the task 0 will acquire the semaphore, it will blink the LED from left to right, then it will release, then release semaphore by task 1. Okay, so like that, and whenever the task 0 will be having a semaphore, the LED will be blink from left to right, and whenever the task 1 will acquire the semaphore, then the LED will be blink from right to left, like that. And if the semaphore is not released by any of the tasks, the other task will go in the waiting state. Okay, so this is the way how the particular semaphore mechanism is used. So this is very important. So semaphore mechanism is actually providing the mutual access to the particular resource. Okay, so by this simulation I think all of you might have understood how the semaphore works. Okay, so if you have any sort of queries, you can mail me at shirsagar.am@gmail.com, or you can call me at 9527 299 300. Okay, so thank you for your patient listening. Okay, good day.